Welcome to your very first section for the class. The first video for each and every section is a little section introduction. That's where we come together face to face for just a minute or two to talk about what exactly we're going to cover in the section and how that's going to fit into the bigger picture goal of the class, which is to get to the point where we can build and launch our own Node.js applications. So here's an example. In this section, section 2, you'll be getting your machine set up for the rest of the class. We'll start by installing Node.js on your computer, and I'll set you up with a text editor that works really well with Node. We're also going to talk about what exactly Node.js is and why it's something you should spend your time learning. We're about to invest a significant amount of time learning something new, and it's always a good idea to know what exactly you're getting yourself into. All right, let's jump right into the section. Before we talk about what Node.js is or explore why it's a useful tool, we're going to go ahead and install it. And the reason we're installing it first is because we're actually going to use a little bit of Node.js in this section to answer those two important questions. In this video, we're going to install Node.js. It's a super easy process, and we're also going to make sure you have a text editor on your machine so we can use it to write our scripts throughout the class. Let's go ahead and get started by installing Node. We can find it over at the official Node website, nodejs.org. Right here on the Node.js homepage, we have the download section for our operating system. Right here, I am indeed running on a Mac, and down below, I have two Node versions I could choose to install. On the left, I have version 8.12.0, which is the current LTS version. That stands for long-term support. And on the right, I have version 11.0.0, which is the current release with the latest features. And that's the version of Node we're going to work with throughout the class. This is Andrew from the future with a quick update. You'll notice that now the LTS version is 10.15.3 and the current release is 12.1.0. I've updated the class, and to get the most out of the course, it is now recommended that you use version 12 or greater. All right, that's it for this quick interruption. Let's get back to the course. Now, if you're seeing a more recent current version, please go ahead and install that. I'm frequently updating this course to always support the latest Node features. So as you move through the class, I recommend installing the newest version of Node possible. Once again, for me, that's currently 11.0.0. So I'm going to go ahead and click that big green button. That's going to download the installer, and it's one of those really easy click next installers. So let's go ahead and run through it. Right here, there's no need to customize anything we see. We'll click continue a couple of times. We'll agree to some stuff we're not going to read, and we'll choose where we want to install Node. From here, all we have to do is authenticate. I'm going to provide my password, and after just a couple of seconds, Node.js will be installed on your machine. And there we go. The Node installer is all done. It says that Node was successfully installed, and all we're going to do is test that by running a single command from the terminal on your machine. We're going to make sure that Node was indeed wired up correctly. To do that, let's go ahead and first close down the installer. We're all done with this. I am going to go ahead and move it to the trash. It is no longer necessary. And what we're going to do now is open up the terminal on our machines. On my Mac, I'm going to get that done by cracking open Spotlight and searching for the terminal application. If you're on Windows, you can use the Windows key to bring up the search bar and search for the command prompt application. If you're on Linux, the exact name and location is going to depend on your distribution. You're looking for something like the terminal, the command prompt, or the command line. Now we're going to go ahead and crack this open, and what we get, regardless of our OS, is the same thing. Stylistically, it's going to look a little bit different, but it is a place for us to type commands. We can then hit enter to run those commands, and we'll see the results right here in this screen. Now, when we installed Node.js, we didn't get a GUI application with fields and buttons and text. Instead, what we got is a command we can now run from the command prompt. We're going to be using this command hundreds of times throughout the course, and we'll learn a lot more about it and how it works throughout the class. For now, though, we're going to use it in one way to check for the Node version installed. So right here, we're going to type out 7 characters. To start, we will run the node command. So we're going to type out node, N-O-D-E, followed by a space, and we're going to provide an argument to this command telling it that we just want to know the version of Node that's running. So right here after that space, it is a hyphen followed by the letter V. Now, if we go ahead and run this, we are going to get the version of Node we just installed. Right here, I'm seeing version 11.0.0, which is indeed the version I installed a few minutes ago. Right here, you might not see the same version I have, but you should see the same version you just installed. Now, what if you're not getting that? Well, if you're not getting a version, that likely means Node wasn't installed correctly. And to simulate what this looks like, I'm just going to mistype Node. So I'll type Node with 2 E's as an example. Then I'll try to use this V argument to ask for the version, but there is no Node command with 2 E's, so what do I get? I get an error saying something like command not found. If you're seeing something like this when you run the correctly spelled command, that means that Node wasn't installed correctly and that we need to address that before you can continue on. To do that, all you have to do is crack open a question in the course Q&A, and I'll work with you to get Node installed correctly. So at this point, we've installed Node.js and we've confirmed that we can actually use it on our machines, and that's where we're going to stop with the terminal for now. I'm going to leave the terminal open as we'll be using it in the next several videos. And if you don't have any previous terminal experience, don't worry. We'll cover all of the commands we end up running. No terminal experience required. That's all we're going to do with Node for now. To wrap up the video, I want to make sure we all have a text editor we can use to write out our Node scripts. So to do that, let's go ahead and explore a couple of different options. Throughout this class, I'll be using Visual Studio Code. You can find and install this over at code.visualstudio.com. Now, there are a few reasons I love Visual Studio Code. It is free, it is open source, and it's available for all operating systems, whether you're running on Mac, Windows, or Linux. It also has one of the best editors I've used in a while, with a fantastic ecosystem of extensions and themes, allowing you to really customize the editor to fit your needs. And we're going to do just that with Node.js. With Visual Studio Code, we can actually debug Node.js right inside of the tool, which is a great feature you don't always see from text editors. Now, there is no reason you have to use Visual Studio Code. It is just the editor I'll be using throughout the class. You're more than welcome to use any editor you're comfortable with. If you already have one that supports JavaScript, then you're already good to go. But if you're looking for something new and you want to try out what is a very cool tool, I definitely recommend checking out Visual Studio Code. Now, there are plenty of other options out there as well. In the past, I've used the Atom text editor in my classes. It's also a great free open source editor available for all operating systems. And there are some good paid editors out there as well. Examples of that would be Sublime Text 3 and WebStorm. Now, WebStorm is definitely more of an IDE than a text editor, but it's also a tool worth checking out. So all we need is to install one of these. If you want to follow along exactly and use the setup I use, I recommend installing Visual Studio Code. So take a moment to get that done. You can pause the video, then come back when you have it installed, and we're going to wrap up the course by just cracking it open. So I'm going to open up from Spotlight, Visual Studio Code, and right here, we're not going to actually do anything with the editor. I just want to make sure we have it installed and we can actually crack it open. So we have Node installed, we've checked that the command works, and we have a text editor where we can now write Node scripts. That is it for this installation video. We're now ready to continue with the rest of the course. In the next 2 videos, as I mentioned, we're going to focus on answering 2 important questions. What is Node.js, and why is Node.js a tool worth using? I'm excited to talk about both of those, so let's go ahead and jump right in to the next one. In this video, we're going to answer a single question, which is, what exactly is Node.js? Node.js came about when the original developers took JavaScript, something that at that point we could really only run in the browser, and they allowed it to run as a standalone process on your machine. So before Node, JavaScript just could not be used as a more general purpose programming language. It was limited to what the browser allowed it to do. So for example, I could use JavaScript to add a click event to this button or to redirect a user to a different page, but there was no way to use the JavaScript programming language outside of the browser to build things like web servers that could access the file system and connect to databases. All of these are things that other programming languages can do without any problem. All of this ended up changing with the introduction of Node.js. With Node.js, JavaScript developers could now use JavaScript on the server side, so they could use the same JavaScript programming language to create web servers, command line interfaces, application backends, and more, all of which we'll end up covering in the class. So at a high level, you know what Node is. Node is a way to run JavaScript code on the server as opposed to being forced to run it on the client in the browser. Now the question has to be asked, how exactly is this possible? And we're going to explore the answer by starting with this one sentence summary on the Node.js homepage. We're going to read this out, break it down, and it's going to shed some light on what exactly is happening here. So Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. And it all comes back to this JavaScript engine. Now, there are all sorts of JavaScript engines out there. Pretty much every major browser has their own. Node.js uses the V8 JavaScript engine, and that's the same JavaScript engine that powers the Chrome browser. And V8 is a Google open source project. The job of the JavaScript engine, whether it's V8 or any of the other ones out there, is to take in JavaScript code and compile it down to machine code that your machine can actually execute. Now, the V8 engine is written in the C++ programming language. That means anyone out there could write a C++ application, they could incorporate the V8 JavaScript engine into their application, and they could extend the functionality that JavaScript provides. And that is exactly what both Chrome and Node.js do. Both Chrome and Node.js are largely written in C++. Now you'll notice right here, it says that Node.js is a JavaScript runtime, and that's true. Node.js is not a programming language. In the end of the day, all of the code we're going to write in this class is indeed JavaScript code. The runtime is something that provides custom functionality, so various tools and libraries specific to an environment. So in the case of Chrome, it provides V8 with various objects and functions that allow JavaScript developers in the Chrome browser to do things like add button click events or manipulate the DOM. Now, neither of those features make sense for Node, where we don't have buttons and we don't have a DOM, so Node doesn't provide those things. Instead, the Node runtime provides various tools that Node developers need. Libraries for setting up web servers, integrating with the file system so you can read and write from disk, and in the end of the day, both Chrome and Node.js are just creating their own modified version of JavaScript. Now, in the end of the day, it's still that same core JavaScript language, but with custom functions and objects injected. Now, this is actually a really important concept, so I've put together a quick visualization to walk us through exactly what's happening here. So let's take a couple of minutes to jump into that. As I mentioned, we have the Chrome browser, and the Chrome browser uses the V8 JavaScript engine. Now, when Chrome needs to run some JavaScript for a particular web page, it doesn't run the JavaScript itself, it can't. Instead, it uses the V8 engine to get that done. So it passes the code to V8 and it gets the results back. Now, the same exact thing is true with Node. Node does not know how to run JavaScript code. It also uses that V8 engine. So when Node needs to run a script, it passes that script down to V8, and in the end of the day, it gets those results back. Now, I mentioned that V8 is written in C++, and I also mentioned that both Chrome and Node are largely written in C++, and once again, that's no coincidence. The reason that both Chrome and Node use so much C++ is that they're both providing bindings when they're instantiating the V8 engine. This is what allows them to create their own JavaScript runtime with interesting and novel features. It's what allows Chrome to interact with the DOM when the DOM isn't part of JavaScript, and it allows Node to interact with your file system when the file system isn't part of JavaScript either. So V8 has no idea how to interact with the file system with JavaScript or what the DOM is. It is up to Node and Chrome to provide implementations for those when running V8. What does this process look like? Well, we have a table. It's not really a table, but it's convenient to think of it as a table. And we have a set of JavaScript methods and objects, and we have a set of C++ functions. So on the left, I've picked two very popular JavaScript methods. Here I have local storage.getItem, which would fetch an item out of local storage, and I have document.querySelector, which would allow me to query some elements from the DOM and then do something with them, like deleting them or changing their contents. Now, it might surprise you, but neither of these are part of the JavaScript programming language itself. You can pull up the specification, you can search for them, but you're not going to find them. That's because they're actually implemented by the Chrome runtime. When Chrome runs a JavaScript file that uses either of these, in the end of the day, some C++ code gets executed behind the scenes, which is responsible for taking care of the functionality. That's why Chrome has so much C++ code. Now, Chrome needs to tell V8 what to do when these methods are called, so Chrome's not just passing JavaScript code to V8, it is also passing down these C++ bindings, creating the context for which the JavaScript code should be executed in. Now, the exact same thing is true with Node.js. Over here, I've picked out a couple of Node.js methods that you'll be familiar with by the end of the next section. I have fs.readFile. Fs stands for file system, and readFile allows me to read the contents of a file from disk. I also have os.platform, OS of course standing for operating system, and the platform method allows me to fetch the name of the platform I'm running on, such as Windows, Linux, or Mac. Now, neither of these methods, once again, are part of the JavaScript programming language. They're provided to V8 as part of the Node.js runtime. So JavaScript doesn't know how to read a file from disk, but C++ does. So when someone uses JavaScript code in Node.js to read a file from disk, it just defers all of that to the C++ function that can actually read the file from disk and get the results back to where they need to be. So once again, we have a series of methods that can be used in our JavaScript code, which are in reality just running C++ code behind the scenes. Now let's wrap up this video by going over a little code example that illustrates some of the differences and similarities between JavaScript in the browser and JavaScript inside of Node.js. So to start, we're going to open up any website. I'm just going to use the Node.js homepage, and we're going to crack open the console. So from here, I'm going to go to Settings, More Tools, Developer Tools, and we're just going to pull up the Console tab. This is going to allow us to run individual JavaScript statements. So right here, as an example, I could type 2 plus 3, hit enter, and I get the result 5 back. I could also create a string with my first name inside of it, the string Andrew, and I could use the string JavaScript method to uppercase to convert that string to uppercase, and I get uppercase Andrew back. Now we can do the exact same thing in Node. Almost all of the Node code we're going to write in this class is going to live inside of files in a larger project, and that'll happen over in Visual Studio Code starting in just a couple of videos. But for the moment, we're going to go ahead and just mess around with Node right here inside of the terminal. So let's go ahead and use clear. This is a standard bash command allowing us to clear the output we're seeing. If you're on Windows, you need to use CLS, that is the version of clear for your operating system. And what we're going to do from here is just run the node command. We're not going to put anything after it, just NODE, and we hit enter. Now what we get here is a little place where we can run individual node statements, also known as an REPL, which stands for read eval print loop. Like the terminal, it's waiting for us to run some commands, but these are actually going to be Node JavaScript statements and not bash commands. So what are we going to do? Right here, we're going to write some JavaScript code and hit enter exactly like we did over here. And I'm going to use the exact same two things. 2 + 3. Enter. What do I get? 5. Then I'll create the string Andrew, and I'll use the string 2. Uppercase, calling it, and what do I get? I get back the uppercase string Andrew. So right here, we can see that all of the core JavaScript features we're used to are still available when using Node.js because those are provided by the V8 engine itself. Now let's head over to the browser and start to explore a couple of the differences. If you've worked with JavaScript in the browser before, then you're likely familiar with the window object. The window object is a reference to our browser window. I can type window, I can hit enter, that's going to dump the entire object to the console, and if we expand it, we can view all of the different methods and properties we have access to, and there are quite literally hundreds of them. Right here, we have some methods related to click events. I have onClick, onChange, and others. And if I continue to scroll down, we have things related to the window size. I have outer height, outer width, and others. Now, all of these make sense in the context of JavaScript in the browser because we actually have a window to work with. What happens if I try to get the window in Node? I'm going to type window, I'm going to hit enter, and I can see I'm getting an error, reference error. Window is not defined. So window is something specifically provided by the Chrome runtime when JavaScript is running in the Chrome application. Node doesn't have a window, it doesn't need window, so window is not provided. Now with Node, we have something kind of similar. We have a variable called global. Global stores a lot of the global things we're going to be accessing throughout the course. And if we scroll up, we can see we have dozens of different properties and methods available to us. We're not going to dive into any of these right now, but we will be exploring several of them as we start to learn about Node.js. Now, does the browser have global? The browser does not. If I scroll all the way to the bottom, I can run something new, type global, hit enter. What do I get? I get global is not defined. I actually misspelled it, but I'll get the same result if I do indeed spell it correctly. Global is not defined. Now, there's another difference I'm going to point out before we wrap things up here. In the browser, I have access to document. Document allows me to work with the DOM. So right here, I have a whole bunch of different elements that make up my page, and I can use document to manipulate them in whatever way I see fit. Now, this makes sense, once again, for the browser where we actually have a DOM. It doesn't make sense for Node where we don't have a DOM. If I try to print document to the terminal, what do I get? Once again, reference error. Document is not defined. Now, in Node.js, we have something kind of similar to document called process. Process gives us various properties and methods for manipulating the Node process that's running. If I dump this to the terminal, we can see there are all sorts of interesting methods and properties, including one, exit. Exit allows us to exit the current Node process. Let's go ahead and actually use it to shut down our little Node example right here. That's going to be process, which is an object, .exit, which is a method. I'm going to call it providing no arguments since it doesn't need any. And all we're going to do is run this statement by hitting enter. What do I get? I can see I'm brought back to the standard terminal where I could run other commands. No longer am I running little Node statements. Now, process, once again, does not exist over in the browser. That is specific to Node.js. If I type out process and dump it, I get process is not defined. So here we're seeing some of the differences between JavaScript in the browser, here specifically Chrome, but other browsers would be the same, and Node.js, which is JavaScript running on the server. That's where we're going to stop for this one. Let's take a quick moment to summarize. Node.js is JavaScript on the server. This is possible because Node.js uses the V8 JavaScript engine to run all of the JavaScript code you provide. Now, Node.js is able to teach JavaScript new things by providing C++ bindings to V8. This allows JavaScript, in essence, to do anything that C++ can do, and C++ can indeed access the file system, so now JavaScript can access the file system through Node. That's where we're going to stop for this one, and don't worry about memorizing all of this. As we move through the course and start to see this in action, I'll bring up the individual pieces again. In the next video, we're going to dive into what is also a very important question: why should I learn Node.js? I'm excited to get to that, so let's go ahead and jump right in to the next video. In the last video, we answered the question, what is Node.js? In this video, we're going to turn our attention towards the why behind Node.js. So why is Node.js a tool you should spend your time learning? And why is Node.js a good tool for the job of building out applications? Now, as you know, based off of the fact that you're here taking this class, more and more when people want to learn a new backend technology, they are choosing Node.js as their tool of choice. The Node.js skill set is in hot demand, with companies like Netflix, Uber, and Walmart all using Node in production. Node's also useful for developers anywhere on the stack. So we have front-end developers who might need to use a little Node here and there to compile their apps or maybe serve up a website they're working with. And obviously, back-end engineers are using Node.js extensively to build out their web app backends, APIs, and command line applications. Now, in the last video, we broke down this first sentence. We talked about how Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. In this one, we're going to break down the other two sentences. There's only 3 total. We got this second one and the third one. Now you'll notice that you don't have those second 2 sentences on your screen. If I were to load up nodejs.org, I just get that first sentence we already discussed. In the past, this was the complete summary on the website, and I've cached it so we can talk about it. In my opinion, I think it's a shame they took it down because it concisely summed up why Node.js is an ecosystem worth getting into. Let's go ahead and start with that second sentence. Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient. Now, let's just focus on non-blocking I/O. What exactly is I/O? I/O stands for input-output, and your Node application is going to use I/O anytime it's trying to communicate with the outside world. So if your Node app needs to communicate with the machine it's running on, that's I/O. For example, reading some data from a file on the file system. If your Node app needs to communicate with some other server, that's I/O as well. For example, querying a database to fetch some records for a given user. That's going to be an I/O operation, and I/O operations take time. Now with Node.js, we get non-blocking I/O. That means that while your Node application is waiting for a response, let's say a response from that database, it can do other things. It can continue to process other code and make other requests. Now, non-blocking is actually from the browser. So non-blocking I/O started in the browser because otherwise the browser would completely freeze up whenever an I/O operation was happening. So if I was trying to fetch some data to render it to a user, while that data was being fetched, the user wouldn't be able to do anything. They wouldn't be able to click links or buttons, and obviously that's a bad experience. With non-blocking I/O, it frees up the browser to allow the user to interact with the user interface while those I/O operations are running in the background. And the same thing is true with Node. We can continue to do other things while we're waiting for those long-running I/O operations to complete, and this is a critical feature of what makes Node so great. And I put together a quick visualization so we can compare non-blocking to blocking I/O. In this quick visualization, we're going to work through 2 code examples. Now, both code examples aim to get the exact same thing done, they just do it in slightly different ways. On the left-hand side, we have a blocking example. On the right-hand side, we have a non-blocking example. And there's no need to write any of this out, as we're just going to explore how these programs would execute using these timelines down below. That's going to allow us to visualize the differences between blocking and non-blocking I/O. Now, what do we have here? We have a bunch of regular JavaScript code. The only thing specific to Node.js is this require function, which is called on the first line of each little snippet. You'll learn all about require in the next section. For now, all you need to know is that it's a way to get functionality from another file. So in this case, both of these scripts, they load in a function defined elsewhere, and they call them a couple of times to perform some I/O operations. The I/O operation for both is attempting to do the same thing. So over here for the blocking example, the goal is to take in a user ID and then go off to a database and actually fetch that user's profile information. And we do the same thing over here in the non-blocking example. So to start, we try to fetch the user with an ID of 1, then we print it to the console. We do the same thing over here using a slightly different pattern, which we'll get into shortly. Then over here, we try to fetch the user with the ID of 2, and we print that to the console, and we do the same thing over here. Finally, both snippets attempt to add up two numbers and print that sum to the console as well, and that's all they do. Now down below, I have some units for each timeline. That's going to help us compare the relative operating speeds. They're not exactly seconds, but for the sake of this example, you can definitely think of them as seconds. And now we're actually going to run through each, seeing how they execute. We're going to start with the blocking example, and for both examples, we're going to ignore that first line. The first line is the same for both, and it's not part of this whole blocking versus non-blocking discussion. So the first thing we really do over here is we pass 1 into getUserSync. The goal here is to go off to the database and get the user profile for the user whose ID is 1. Now, what does that look like? Well, down below, it looks a bit like this. Here I have a block representing the time this entire operation takes to complete. And in this case, I've chosen to make the length of our I/O operation 2 seconds. And that's going to be the exact same length of all I/O operations in these examples, regardless of whether it's blocking or non-blocking. So this includes everything. It includes initiating the request and actually waiting for the database to fetch the data and send it back to our Node application. So once that's done, what do? We go ahead and just print user1 to the console. That is not an I/O operation, and it runs really quickly. From there, we continue working through our program one line at a time. We go one after the previous. So right here, what do? We have user2, and we get the second user by passing 2 into getUserSync. Once again, we wait 2 seconds to actually get that second user. Right here, these two blocks are the exact same length. The next thing we do is we go ahead and print that second user. That happens on line 7. Once again, not an I/O operation. It runs really quickly. And the same thing is true of the last thing we do, which is we calculate and print the sum. So this is the order of operations, and this is the entire time it takes to run. In this case, let's say it's basically 4.5 seconds. Now you'll notice the bulk of this 4.5 seconds is taken up by fetching second user and fetching first user. And while that's happening, our app isn't doing anything. It's waiting for the database to send the data back. It's not actually doing any work on its own. Now let's go ahead and run through the example on the right to see how this differs even when the I/O operations still take 2 seconds. The first thing that happens over here is the same thing that happened over here. We are attempting to fetch the user with the ID of 1. So what does that look like? Well, you'll notice that over here, we're actually passing a function in as our second argument to get user. This is using the callback pattern, and if it's something you're not familiar with, if this code looks really foreign, that is a-okay for the moment. We're actually going to cover all of this in detail in the class. For now, we're just using it to illustrate at a high level the differences between the two patterns. So over here, what do? We start to fetch the first user. Now, the first thing you're going to notice is that this is not a 2-second operation. It happens basically instantly. That's because we're not waiting for the response from the database. That's the long-running I/O. Instead, we are just starting that process, allowing it to run in the background. So right here, we are essentially registering our I/O event with Node.js, telling it to call this callback when at some point in the future, we get the response we were hoping for. Now, the same thing is true down below. So the next thing we do is we actually start the process of fetching the second user exactly like we did up above. So at this point, Node is actually waiting for two long-running I/O operations to complete, and they're both happening in the background. It's not taking up our application's time, preventing it from doing other things. And we can prove that by talking about the next step. The next thing that happens is we actually calculate and print our sum. These two lines down below, they do not care about the user response for either user 1 or user 2. They should be able to operate completely independently, and that's what we're seeing right here. There's no need to wait for those two responses before calculating and printing the sum. Now what happens? Well, I mentioned that regardless of which example we're working with, the I/O operation doesn't get shorter. It still takes those 2 seconds. So right here, I have a box of the exact same width as our 2 boxes over here, and it's a dashed box, and it represents the time our Node app has to wait for a response to come back. Now, the nice thing is that while it's waiting, it can still do other things. So while it was waiting for user 1, it was able to start up another request, and it was able to calculate and print the sum. Now, after those 2 seconds, we still get the user data back. This is when Node.js calls our callback function, and we are able to print the user, and that's what I see right here. Next up, we wait for that second request. This starts just a little bit later than the first, and it finishes a little bit later. And once we get that data back, we are able to print the second user to the console. If we look at the total operating time, I can see that the non-blocking example was able to finish in just over 2 seconds, while the blocking example was able to finish in just over 4 seconds, a difference of 50%, making the non-blocking example twice as fast. Now, obviously, that's because we were able to overlap the part of our application that took the longest, which was waiting for the I/O to finish. Down below, we were able to wait for both at the same time, and while we were waiting, our app could even perform other things like firing off another request or calculating and printing the sum. That just is not possible using a blocking model. So in this course, we're going to be working with non-blocking code throughout the class, and that's what makes Node so ideal for things like server-side development, where we're making web servers and application backends. It's going to allow your Node app to process multiple requests at the exact same time for different users. So you could be fetching some data for user 1 while processing a new request from user 2. Now let's go ahead and run some Node code to actually see these 2 examples in action. Right here, I'm going to put on a quick demonstration actually running the 2 files we just had over in that visualization. On the left, I have my blocking example, character for character, what I had in the other file, and the same thing is true on the right with the non-blocking example. Once again, you don't have to worry about opening this project up or writing this code. This is just for demonstration purposes. We'll start diving into coding together in the next video. For now, what we're going to do is run these 2 scripts to see how they execute, which is going to be exactly how we described them in the visualization. On the left-hand side, I'm going to use one terminal for the blocking example. On the right-hand side, I have a second tiny terminal for the non-blocking example. Now, to actually run a file, we still use that node command, followed by a space and the file name. So here, node space blocking.js is the file I'm trying to run. Now, to make things easier to see, I've delayed the I/O operations to take 5 seconds, so it's a bit easier to talk about things as they're happening. Let's go ahead and kick off the blocking example. So what happens? Nothing. We are sitting here and we're waiting, and we are waiting for a full 5 seconds before that first user comes back. There it is. We have their ID and their name. Then we wait another 5 seconds to get the second user. Finally, the sum prints exactly as we saw over in the visualization. So 5 seconds for Jess, 5 more seconds for Mark, then basically instantly after Mark printed, we got 34 printing. So this is the blocking example for a total runtime of just over 10 seconds. Now let's try the non-blocking example. In this case, getting the user still takes a full 5 seconds. So right here, node space, the file non-blocking.js. I'm going to go ahead and run it. And once again, we get the number printing right away. It started up the 2 I/O operations. It printed the number. Then 5 seconds later, both basically printed at the exact same time. That's because we were able to overlap the process of our Node app waiting. So the total runtime here for our non-blocking example was just over 5 seconds once again, running twice as fast as the blocking example over here. So that is it for our little illustration of blocking versus non-blocking. We're going to talk a lot more about this a bit later in the class when we start to get into some more advanced Node.js application code. For now though, we have done a pretty decent job at exploring this second sentence. Node.js uses an event-driven non-blocking I/O model that makes it lightweight and efficient. So we now know what non-blocking I/O is, and we've seen that it definitely creates a more lightweight and efficient application. And event-driven is just that process of registering those callbacks and having them called when the I/O operation is done, and it's something we will talk about in detail later on in the class. The last sentence we have here, Node.js's package ecosystem NPM is the largest ecosystem of open source libraries in the world. Now, NPM is a tool that was actually installed on your machine when Node was installed, and you can find the website at npm.js.com. Here, a website we'll be spending plenty of time in the class. You can search for all sorts of pre-written packages that you can use inside of your application. So if you want to validate emails, there's a package for that. If you want to send emails off or communicate with a database or create a web server or pretty much do anything else you can do with Node, there are libraries and packages that make your life much easier. We're going to make heavy use of NPM packages throughout this class, which is exactly what real developers do when they're building out Node applications. This is something we'll start to explore in the very next section. So we know a little bit about what Node is and why it's a tool worth learning. In the next video, we're going to wrap up this little introductory section by actually creating and running a script on our own. I'm very excited to get to that, so let's go ahead and jump right in to the next video. In this video, you're going to create and run your very first Node.js script. Now we're going to keep it simple for the moment. This is actually the last video in this little getting set up section. In the next section, which starts in the next video, we'll move on to explore Node in detail, and we'll start to build out meaningful applications. For now, the goal is to just give us a place to even put our code, and we're going to figure out how to run our scripts. Let's go ahead and kick things off by actually closing down the terminal. The terminal or the command prompt on Windows is not something we're going to use throughout the rest of the class. Instead, I will be using the integrated terminal built right into Visual Studio Code, so we don't have to switch between windows. I'm going to close that down, and let's just get a bit organized. On the left-hand side, I'm going to put the browser. That's where this will stay for the rest of the class. And on the right-hand side, I'm going to put Visual Studio Code. Now the goal is to give us a place to put all of the files and folders we'll end up creating for our projects throughout the class. Right here, I'm going to expand the tree view, and you'll notice that there is no folder open. So let's go ahead and create one, and then we'll open it. I'll be using the File Explorer for my operating system, which is the Finder, to create a new directory. And you could put that directory wherever you wanted to. I'm going to put mine right on the desktop. So right here on the desktop, I'll be creating a new folder, and I'm going to call this something like node-course perfect. This is the location where we're going to put all of the stuff we write in this course. And this is the folder we're going to open up in Visual Studio Code. I'm going to shut down the Finder and open up that directory. Right here, on the desktop, I have my Node course folder, which I'll double click. This is going to open up that directory in Visual Studio Code, which I can see based off of the window title and the folder title over here. Now we can actually add files and folders to this directory to build out our projects. Now, as I mentioned, we're going to keep things pretty simple in this video. We're going to have a one-line script just to make sure everything is working correctly. So let's go ahead and create it. Right here in the Node course folder, I'm going to create a brand new file, and we can call this whatever we like. I'm going to call it something like hello.js. Remember, Node.js isn't a programming language. In the end of the day, all the code we write is JavaScript code. So right here, I'm using a .js extension exactly like I would if I was creating JavaScript files that I intended to run in the browser. As the first and only line in this file, we're going to use console.log to print a message to anyone who runs the script. So right here, we'll be accessing the console object. We'll be using the log method on there, calling it as a function and passing in a single argument right here. That is the string, something like welcome to the class. Now you should be familiar with all of this since the basics of JavaScript are indeed a prereq for this class, and there we go. We now have a simple Node script. Now you might say, hey, this really isn't a Node script, this is a regular old JavaScript script, but it's important to note that console.log, it's not actually part of the JavaScript programming language. This is always part of the runtime, whether that comes from a browser like Chrome or Node.js. So there's no better time than now to show you where the Node docs live. Over at Node.js.org, we have this docs page up top. On the left-hand side, I have two API pages for the two versions shown on the home page. I'll click on mine. Then down below, I have a long list of different modules we can work with. This one, the one that we just used, is called console. I'm going to expand that, and what do we get? We get all sorts of different ways we can use console, and down the list, we do have the one that we just used, console.log. So the documentation for Node is a great way to get comfortable with the features, and we'll be referring to it a lot throughout the rest of the class. Right here, though, we can see that console.log is something provided by Node, and if I click that, it brings us down to some examples as to how we can use it. Now let's go ahead and actually run our script to see our little message print to the screen, then we'll be done with this video. As I mentioned, we are going to use the integrated terminal throughout this class. It makes it really easy to run terminal commands from right inside of Visual Studio Code, and you can find it by going up to the terminal menu and clicking New Terminal. Also take a moment to note the keyboard shortcut. I'm a huge fan of keyboard shortcuts, so for me on a Mac, it is Control-tilde. I can just type that from anywhere to crack open a new terminal, and here I have it. Now we're already navigated to the correct location. Here I'm running commands from inside of the Node course folder, and you should see that as well. And what we're going to do is use that Node command once again. Now in the past, we had used Node just like this to run individual statements. When we have a script we want to execute, we use space, and then we provide that script name. So right here, Node space hello.js, matching up with the file name we created. Now we can actually execute this little Node application by hitting enter to run it. And what do I get? I get my message, welcome to the class printing, and this is fantastic. That's where we're going to stop for this one. We now have a place to put our projects and our project files, and we know how to run Node scripts. So we're done with this video and we're done with this section. In the next section, we're going to dive in and start to learn how to use Node.js to build out backend and server-side applications. I am beyond excited to get to it, so let's go ahead and jump into the section introduction for the next one.